In this video, I'm going to be working through a solution to a question sent in by a student. And this question is hypothesis testing with the binomial distribution. It says the discrete random variable follows the binomial distribution of x belongs to a binomial distribution of n 30 and p 0.28. Part A says find the probability of 5 being less than or equal to x, which is less than 12. So the first thing that I'm going to do is say what values can this probability here take? Well, if we think about it, it's going to be from 5 to 12, isn't it? It can equal 5. So there, 5, 6, 7, 8, 9, 10, 11 and 12. But if we have a look, it can equal 5, but it's got to be less than 12. So it cannot equal 12. So the values that this probability can take is 5 all the way up to 11. Now, what we need to do is somehow translate this probability into less than or equals so that we can work with a binomial distribution. So to convert this into a less than or equal, if we look at our highest value, all of these numbers are less than 11, aren't they? And we want to include the 11, so we're going to need the probability of x being less than or equal to 11. So that's the first thing. Probability of x being less than or equal to 11. But the probability of x being less than or equal to 11 is all of these numbers and 4, 3, 2 and 1. And we don't want to include these numbers either. So we need to look at the 5 and take away the probability of x being less than 5. So, minus the probability of x being less than 5. But we need to convert all of these into less than or equals. The probability of x being less than or equal to 11 is okay, but the probability of x being less than 5, we can say is the probability of x being less than or equal to 4. Now we've got them all in less than or equals, so we're going to say, putting little x as 11, n as 30 and p as 0.25. Once you do that in your calculator, you get 0.89390876. And when you put n as 4 following this binomial distribution, you get 0.04954,108. And now what we're going to do is just take those away. And once you do that, you get 0.84436768. And that's our final answer. We're not going to round the answer because it hasn't asked to do. But what we can do if you want is maybe give it to 4 decimal places like the tables, and you won't be penalised either way. Now it says past records from a large supermarket show that 25% of people who bought eggs buy organic eggs. On a particular day, a random sample of 40 people is taken from those that had bought eggs, and 16 people are found to have bought organic eggs. Part B says test at the 1% significance level whether or not the proportion of people P who bought organic eggs that day had increased. State your hypotheses clearly. So the first thing we're going to do is look at this important sentence. State your hypotheses clearly. So let's do that first. Our null hypotheses and our alternative hypothesis. We're going to have P because that's the number, that's the proportion of people. So P equals and then our probability, 0.25. And then P and the alternative hypothesis is going to be greater than, because we're saying has it increased? So greater than 0.25. Now our next step is to say, assuming that H0 is true, x will belong to a binomial distribution of n, which is our sample size, and they've told us they sampled 40 people. And if H0 is true, then our p equals 0.25. Now we need to decide which tail we're looking at, and because we have a greater than symbol here, we're looking at the upper end. So we're going to have a look now and say, from those that had bought the eggs, the 40 people that had bought the eggs, 16 are found to have bought organic. So let's work out the probability of x being upper end, so greater than 16. And what we need to do is again convert this into a less than or equal. So if we're greater than 16, it's any number after 16. So any number below that is probability of x being less than or equal to 16. So 1 minus the probability of x is less than or equal to 16 will give us the answer. And be careful, it's not 15 here, it's 16 because it can't equal 16 here. So when we put that in our calculator, we get 1 minus 0.988438663. And 1 minus that gives us 0.0115637. So that's the probability, assuming H0 is true, that we are greater than 16. Now we're going to compare that with our 1% significance level. And as we can see, that's greater than 0.01 or 1%. So therefore, if it's greater than, we're in the acceptance region. So what we can say then is now, let's make a comment saying, hence, accept H0 as there is insufficient evidence to suggest, and then looking back at the context of the question, the proportion of people who bought organic eggs had increased. And that's our final answer for part B. Looking at part C, it says state the conclusion you would have reached if a 5% significance level had been used for the test. So don't carry out the test again. Let's just have a look at this probability. If we rewrite that probability, that's 0.01156137. Now, we compared that with a 1% significance level because the question told us. But now it's saying, what would have the conclusion been if we used a 5% significance level? So comparing that with 5%, which is 0.05 as a decimal, that is clearly less than 0.05. And therefore, we are in the critical region. So then we would say, hence, reject H0 as there is sufficient evidence that the proportion of people who had bought organic eggs may have increased. And we have to mention here, I said it suggests. Here I've said may, then we have to say it might have done. It's not certain, but from this hypothesis test, it may have done. And that is your perfect solution to your exam question.